Well, hello everyone. What we're doing today is starting our next chapter, or next section I should say, 13.4, to do with motion in space. The equivalent to this would be when you did things like in Calc 1. If you had a function, let's say it's called your position function, S of t, it would typically be called your position function. If you differentiated that, you would get the velocity function, very often called v of t. And if you differentiated that, you would get the acceleration function. Now we know by experience that these are very useful things to know about a moving object, but this is really a moving object in 2D. We have to change the concepts a little bit when we think of a moving object in 3D. So let's imagine we've got our space curve, this guy here. Then we have r of t, which is our space curve. We could always think of that as the position function. Now, if we differentiate that, we get the velocity function, which we call v of t. Now, if we find the magnitude of the first derivative, if we find the magnitude of the velocity function, we get the speed function. Now, velocity is not the same as speed. In 2D, it's a little less obvious. But even in 2D, there is a difference between velocity and speed. Speed is the speed you're going at. I'm going 40 miles an hour. And velocity has a direction associated to it. So I'm going up 40 miles an hour, or I'm coming down the way 40 miles an hour. Well, when you talk about 3D and beyond, a velocity, as you can see, is clearly a vector. A velocity vector would be maybe a vector like this. What that's doing is it's telling you how the X, Y, and Z components are individually changing with time. So you could have a lot of velocity in the X direction, but not as much in the Y and Z, for instance. So that's velocity. Speed, however, which is the magnitude of that, is telling you I'm going at 90 miles an hour in whatever direction this happens to be pointing in, or I'm going negative 90, I guess, if it was going the opposite for it. And last but not least, we can find the second derivative of the position function, and that is the same thing as the first derivative of the velocity function, which in turn is called the acceleration function. Strictly speaking, I should say the acceleration vector. And velocity vector. And call it a speed function.